Imagine walking into a facility where thousands of gallons of boiling liquids and high-pressure steam are constantly surging through massive metal pipes. The physical danger of a modern continuous manufacturing plant is hard to overstate. An unexpected shutdown at this scale drains millions of dollars in a single afternoon and triggers immediate, high-stakes safety protocols. So how exactly does a plant manage thousands of highly volatile chemical reactions and pressure changes at the exact same time, 24 hours a day, without making a single mistake? You might assume the answer is one incredibly powerful computer, but managing this level of physical risk requires an infallible organizational structure. Decades ago, facilities relied on centralized control. Every single pipe, valve, and sensor on the factory floor was wired back to one rigid central location. This setup creates a single point of failure. If that one central brain loses power or glitches, the entire facility goes blind, and the whole plant has to shut down immediately. To solve this, engineers developed the Distributed Control System, or DCS, which re-architects how the factory processes information. Instead of a one-man band trying to play every single instrument at once, a DCS operates like a symphony orchestra. Responsibilities are divided up among distinct, specialized sections working in unison. By distributing the brain power out across the factory floor, we eliminate those catastrophic single points of failure. Let's look at how this orchestra is arranged, starting from the ground up. The bottom layer of the DCS pyramid is known as level 0, or the field level. This is the only layer that directly touches the physical process of manufacturing. Down here, we have our sensors. These are the eyes and ears of the plant, constantly measuring real-world variables like the temperature of a liquid, the pressure inside a tank, or the rate of fluid flowing through a pipe. Alongside the sensors are the actuators. Think of these as the muscles of the operation. They do the heavy lifting, physically opening valves, turning on pumps, or spinning massive electrical motors. In our orchestra, these sensors and actuators are the instruments themselves. They are the tools out on the floor actually making the noise. Without level 0, the rest of the control system is completely paralyzed. It has no way to perceive what is happening in the factory and no way to physically alter it. Moving one step up, we reach level 1, the control level. This is where the actual thinking and automated decision-making take place. The plant floor is divided into discrete zones. Each area gets its own dedicated controller, acting as a section leader. This introduces a critical safety feature, redundancy. If a controller fails, a backup immediately takes over, keeping the process running. By localizing control and giving every section a backup brain, we guarantee that a localized glitch stays local. It never cascades into a plant-wide meltdown. Above the automated controllers sits level 2, the supervisory level. Here, human operators monitor the entire synchronized operation from a safe, quiet distance. They interact with the system through a human-machine interface, or HMI. This glowing digital dashboard takes the raw data surging up from the field and translates it into clear, visual information. The human operator acts as the conductor of our orchestra. They aren't out on the floor manually turning valves. Instead, they guide the overall tempo and harmony of the plant. The HMI allows them to receive instant alarms if a pipe gets too hot, optimize production workflows, and make strategic decisions based on real-time data. Level 2 elevates human workers from doing dangerous manual labor near boiling chemicals, allowing them to execute big-picture management to keep the facility safe. Finally, the system caps off with levels 3 and 4 at the very top, manufacturing execution and enterprise resource planning. These top levels don't control machinery. Instead, they process raw factory data to manage production schedules, supply chains, and plant finances. If the operator is the conductor, these upper levels are the theater management. They sell the tickets, balance the budget, and plan the orchestra's touring schedule for the year. A fully integrated DCS bridges the gap between the raw physical machinery on the factory floor and the corporate business strategy in the boardroom. This technical diagram of a branching, hierarchical network architecture demonstrates exactly what a DCS is, an organizational philosophy. It pushes critical decision-making authority down to the lowest, safest possible level across many interconnected nodes. This distributed architecture is the exact reason our modern society can safely refine oil, treat city drinking water, and generate electricity 24 hours a day. The continuous, flawless performance of our infrastructure depends entirely on this unseen digital teamwork. By dividing the labor and layering in automated backups, the DCS allows thousands of volatile components to work together with the reliable precision of a synchronized orchestra. If you want to learn exactly how operators control this massive orchestra, hit subscribe and check out our next video on how human-machine interfaces actually work.